आइए हम सुने विज्ञान की अनकही कहानियाँ। आइए हम सुने विज्ञान की अनसुनी कहानियाँ। एक नई दुनिया की आवाज आपकी आवाज, विज्ञान की आवाज, की आवाज।
We bring you all a podcast series on STEM popularization, that is, science, technology, engineering, mathematics, and medicine, supported and catalyzed by the National Council for Science and Technology Communication, the Government of India. Program is produced by Media for Community Foundation. Creative content and technical support is given by Farzeen Sultan.
एक नई दुनिया की आवाज आपकी आवाज, विज्ञान की आवाज, की आवाज, की आवाज।
इस खुले से आसमान में हमें एक रोशनी की चादर प्रदान करता हुआ, एक एनर्जी का सोर्स बनता हुआ ये सूरज है। और आज हम बात करेंगे इसी जायंट बॉल ऑफ एनर्जी सूरज के बारे में। आपने सोचा है सूरज कैसे अपनी ताकत हम तक भेजता है और इसके अंदर इतनी सारी एनर्जी कैसे समाहित है? इसका जवाब हमें मिलता है साइंस की एक स्पेशल डोमेन में जिसका नाम है सोलर फिजिक्स। सोलर फिजिक्स का मतलब है सूरज के बारे में साइंस की स्टडी। आप सोच रहे होंगे ये क्या बात हुई, पर जरा सोचिए, सूरज को रोज देखते हैं लेकिन कभी सोचा है कि सूरज के अंदर किस तरह की पार्ट छुपी हुई है? सूरज एक एनर्जी फैक्टर है जहां हर सेकंड एक इंटरेस्टिंग प्रोसेस होता रहता है। इस प्रोसेस का नाम है न्यूक्लियर फ्यूजन, जिसमें सूरज के अंदर का हाइड्रोजन गैस एक दूसरे के साथ मिलके एनर्जी बनाता है। जब ये हाइड्रोजन एटम्स मिलते हैं तब मैसिव अमाउंट ऑफ एनर्जी रिलीज होती है जो बहुत पावरफुल होती है। ये एनर्जी सूरज के कोर यानी अंदर वाले हिस्से से निकलकर स्पेस में ट्रैवल करती है और कुछ 8 मिनट बाद हमारे पास आती है। हमारे लिए ये एनर्जी जिंदगी का सोर्स है। बिना इसके ना तो हमारी रोशनी होती, ना गर्मी और ना ही हमारी जिंदगी चल पाती। ये जो प्रोसेस सूरज के अंदर हो रहा है वो इतना पावरफुल है कि हर सेकंड सूरज अपने मास का एक छोटा हिस्सा एनर्जी के रूप में भेज रहा है। और आज जो हम सोलर फिजिक्स के बारे में जान रहे हैं वो सिर्फ इसलिए नहीं कि हम सूरज को समझ सके, बल्कि इसलिए कि हम अपने अर्थ के लिए बेटर एनर्जी सोर्सेज ढूंढ सके, जैसे सोलर पावर। तो सूरज से मिलती एनर्जी ना सिर्फ हमारी दुनिया को रोशन करती है, बल्कि ये हमें सस्टेनेबल और क्लीन एनर्जी के सॉल्यूशंस भी दे सकती है। और इसी पर काम कर रहे हैं एरीज यानी आर्यभट्ट रिसर्च इंस्टीट्यूट ऑफ ऑब्जर्वेशनल साइंसेज में साइंटिस्ट डी के पद पर कार्यरत डॉक्टर कृष्ण प्रसाद।
सबसे पहले जानेंगे एरीज यानी आर्यभट्ट रिसर्च इंस्टीट्यूट ऑफ ऑब्जर्वेशन साइंस में कार्यरत इस कृष्ण प्रसाद के बारे में।
I'm S. Krishna Prasad. I'm a scientist D at ARIES. So I did my PhD from the Indian Institute of Astrophysics in Bangalore. After that, I moved to UK to do a postdoctoral fellowship there. I worked there for 5 years, five and a half years. So later, I got a senior postdoctoral fellowship in Belgium in KU Leuven. It's a Catholic University Leuven. So I did a second postdoctoral fellowship there. After that, in 2022, I moved here in October 2022. I moved here as a faculty, as a scientist here at ARIES.
सर का एरिया ऑफ रिसर्च क्या है, आइए जानते हैं।
So I work in solar physics. Essentially, solar physics means physics of the sun. So physics of the sun spans across several areas, starting from the nuclear reactions happening inside the sun to outer eruptions that happen on the sun that can impact life on Earth. So it spans a vast range of areas. We are of course living in the solar extended solar atmosphere, which we call heliosphere. We are living in that atmosphere currently. So in this, obviously, because we are living in the atmosphere, extended atmosphere of the sun, our life is being impacted by whatever things happening on the sun. So the physics of those events, several dynamic events that happen on the sun, is what I study.
अब जानेंगे सर की रिसर्च आम आदमी और स्टेम के लिए कैसे यूजफुल है.
What happens typically is, I mentioned that we study the physics of the sun, right? So on the sun, several dynamical events happen especially in the atmosphere. Inside it is pretty calm. It is very dense inside the sun. So if you look at a typical image of the sun, if you even through several filters, so several glasses during eclipses, you may recall, you can look at the images of the sun. It looks pretty smooth and calm, apart from few dark spots which we call sunspots. Apart from that, it looks pretty smooth and calm. But that what we see during those images or during those live visuals are only the surface of the sun. If you go into the atmosphere of the sun, so the atmosphere of the sun is pretty dynamic. It has several violent eruptions happening in the atmosphere, including small scale jets. The small scale what we call on the sun are much bigger than the size of the earth, for example. So those small scale jets, there are huge eruptions happening in the sun. There are also tornadoes happening on the sun. There is also so-called rain happening on the sun. It is of course not made of water droplets like we see rain here. They have rain in terms of plasma falling as a rain. So, and then there are massive eruptions, like I mentioned, so-called flares and coronal mass ejections, where certain amount of plasma within the solar atmosphere is being ejected along with the magnetic fields, and that travels in the atmosphere around the sun, and that can impact, if it is coming towards the direction of the earth, that can impact life on earth. So these are the, direct impacts. So if you ask the benefits of the common man, I would rather say the impacts on the life of common man. So what happens is that when these specific type of eruptions, specific energy of eruptions, these magnetic eruptions bring massive amounts of charged particles, and then they induct these charged particles into the atmosphere of the earth. Thankfully, fortunately, we have magnetic field of the sun that prevents these charged particles, prevents these magnetic fields from entering. But then there are few configurations that is possible in the magnetic cloud that is ejected from the sun that can interact with the earth's magnetic field, and occasionally it can disrupt the magnetic field of the earth itself. Then that lets huge amounts of charged particles enter into the earth's atmosphere. They, of course, again, the earth's atmosphere is dense enough that those charged particles do not directly come and reach the surface of the earth, so they do not cause, for example, the cancerous diseases. Those are possible because these charged particles are ionizing the cells in your body and then disrupting DNA and then causing generations to their mutations. That doesn't happen because of the dense atmosphere we have. However, they can disrupt the technology, they can disrupt the power grids, for example, because these are involved in charged particles, huge transmission lines we have. The currents can be induced in those transmission lines, huge currents, and those currents can disrupt transformers, causing blackouts in certain parts of the world. If those blackouts happen, it is difficult to recover. And of course, this is one particular thing. There are also so-called radio blackouts, which means because of these charged particles entering into the Earth's ionosphere or outer atmosphere of the sun, outer atmosphere of the Earth, so the radio communication is disrupted. So the way we communicate with each other is using these radio waves. So these radio waves bounce back in the outer layer of the Earth's atmosphere and then come to the Earth's surface, bounce back, and then that is how we communicate. Even though Earth is a sphere, from any part of the Earth, we can from one point of the Earth to the other point, even if it is exactly diametrically opposite, we can communicate. But this can get impacted. And GPS, for example, GPS might sound, the GPS which we use in phones, even if it doesn't work for 1 hour, 1 day, it doesn't matter to me. But the GPS is also being used for example, the navigation of planes, navigation of ship. So that navigation, if it gets disrupted, and for example, the bank, if all the digital systems, including the banking systems, if they get disrupted, then the amount of chaos that is going to bring is unimaginable. So this is the kind of impact that can happen because of these massive eruptions coming from the sun. So sun is a huge ball of gas in space. So that huge ball of gas is generating all the energy which we can think of, all the energy that is sustaining life on Earth, for example. Not just sustaining life on Earth, all the other, for example, planets or the planetary positions, everything is being sustained by all the energy created by the sun. So the way this huge ball of gas is generating this energy is, of course, there are other processes which we call nuclear fusion. So that happens inside the sun because of this. To understand how huge this ball of gas is, if we imagine Earth is a small ball, so you can fit in over millions of these balls, millions of Earths inside the sun. That's how massive it is, how huge it. In terms of mass, for example, if you combine all the planets and all the planetary bodies and including the sun, if you say that is 100% of the mass in the entire solar system, out of that 99.8% is within the sun only. Rest 0.2% is distributed among all these planets, including Earth. Earth is not even the biggest planet. As you know, Jupiter is the biggest planet in the solar atmosphere. So Earth is one such planet contributing only this 0.2% of the mass, not even a fraction of that 0.2% of the entire mass of the solar system.
सर की पास्ट, फ्यूचर और प्रेजेंट रिसर्च क्या है, आइए जानते हैं उनके बारे में.
So, I mean, I will try to be as less technical as possible. So, what I work on essentially is so-called wave in the atmosphere of the sun. So these waves, of course, we know several kinds of waves. If we see there is a ripple in the water body, that's a wave propagating. The fact that we are speaking, communicating, this is communication is happening through acoustic waves. My voice is perturbing the pressure in the surrounding ambient air, and that perturbations are propagating. This is one type of acoustic wave. There are different types of, if you play a guitar string, you have a transverse wave propagating along the string. So there are different types of waves in the physical atmosphere that we know. So similarly, in the atmosphere of the sun, there are different types of waves propagating. We study, I specifically focused on studying these waves. The benefit is that there are there are certain technical problems which does not match with the known physics. So to understand what exactly is happening, why it is violating the physics laws we know in the solar atmosphere, we need some different source of energy. That source of energy is being, our understanding is that that source of energy is being transported by these waves. So we study these particular waves. So I did my PhD studying these particular waves before. I also study these massive kernel loops. So these loops are of the scale of, again, at least 10 times more than the size of the Earth, for example. That is huge. These huge loops called kernel loops. So how the structure of kernel loops is forming. This was my previous, for example, if you consider the past area of research during my PhD. And then present, I'm doing, for example, the numerical simulations. So, we simulate these in the computer. So how these waves are propagating, what are the consequences in the solar atmosphere. We simulate that and try to match with the observations. So that I started doing in the recent past, and that is ongoing. So that I consider as my present activity happening, simulations and trying to match with huge observations from very big telescopes. We have a very big 4-meter class telescope in Hawaii. So that has been recently commissioned. That is the biggest solar telescope ever to study the sun. So the observations from that, how do you match with the simulations? That is my current ongoing research. In the future, what I'm planning currently, what I'm getting into is sort of building instruments. So building instruments, so some sort of, we are planning a telescope here. So that is about 25 centimeter telescope to construct, to make solar observations in multi-wavelength bands in ARIES. So this is something I am planning to do in the future.
सर की रिसर्च में इंडिया कहाँ स्टैंड करती है, आइए जानते हैं.
So again, this is what I said earlier is that solar physics is huge, starting from nuclear reactions happening inside the sun that can relate to other areas of physics as well, particle physics, for example, to the coronal mass ejections or the heliosphere or planetary bodies. So it extends a vast range of areas. So my area exactly is studying the physics of the solar atmosphere. If we say who are all, how is India positioned in terms of this area? I would say it should be around top 10%. So I believe our research is the top 10%. It was not as much before, but in the recent past, the number of groups working in this area is growing in India. We have several new groups being started in, for example, IITs, ICERs, which are recruiting people working in this area, and they are being started. So in India currently, I would say the solar physics is rapidly growing. So in that sense, I would say we are there roughly about top 10%. We also have the recent launch of Aditya L1, the first ever solar satellite from India. So observing there, it has its own unique features that has not been done before, which we are doing currently. So in that sense, we are at the forefront, but the number of groups utilizing this data and pushing this are rapidly happening.
इंडियन इंडस्ट्री इनकी रिसर्च से कितनी एसोसिएट है, आइए जानते हैं.
Yes. So if you're talking about Indian industries, so the participation of Indian industry is currently not as much. But there are several research agencies which again build several parts. For example, for the Aditya L1, for example, the mission was being completely by Indian different research groups across India. So there are several, I presume, several research institutes are involved in building this instrument. Several research agencies are involved, but industry as such is not directly involved so far. But even if I compare abroad, for example, the involvement that can happen is in building instruments. So that building instruments is where the industry can collaborate. We can collaborate with industries to build cutting edge instruments so that we can make better observations of the sun. So that is what I believe. Yeah.
चलिए आप जानते हैं सर के रिसर्च पेपर जर्नलिस्ट के बारे में.
I work on, for example, supersonic downflows. Supersonic in the sense that we know jets, supersonic jets. So which means they travel at speeds larger, greater than the speed of sound in that medium. So there are so-called supersonic downflows that happen in the solar atmosphere. These supersonic downflows, how they are originated in the solar atmosphere with respect to different layers of the solar atmosphere. Something I worked on in the past few years. So that paper that I presented in a conference in UK. So there I got a so-called Winton Prize Best Poster in terms of postdoc. That is some award I received. Apart from that, I have received Best Thesis Presentation from the Astronomical Society of India during my PhD. I mean, just after my PhD for the Best Thesis Presentation. Apart from that, I received several grants. One of the grants is the Senior Postdoctoral Fellowship in Belgium in KU Leuven. That is a Belgian funding agency which awarded that fellowship. And I also received here so-called startup research grant from the Indian National Agency, which used to be the Science and Engineering Research Board, SCRB. Currently it is ANRF, Anusandhan National Research Foundation. So they awarded this startup research grant for me. There are other minor grants that I received apart from this.
अंत में साइंस आम आदमी तक कैसे पहुंचे, इस पर सर क्या कहते हैं, आइए जानते हैं.
Yes. So, I mean, this is extremely important. So, to reach to the common man and try to explain what exactly you're doing, this is very, very important. And I'm very glad that such podcasts are coming, and then they are trying to reach to the common man and trying to educate them on this. I have myself conducted several outreach activities, in the sense that I gave a lecture in the nearby college. I went to schools during my PhD even and tried to demonstrate telescope viewing, etc. And then even when I was in abroad, for example, when I was in UK, there was a planetary transit, Venus transit happening. And then during that transit, we interacted with the local public there, and we tried to explain what exactly is happening. We conducted a recent eclipse expedition in US. So we from ARIES we built a telescope, and then we took this telescope all the way to US in April last year, and then observed one of the greatest eclipses last year that happened across parts of US. So we observed and we got the data. We got not only the scientific data, along with that we interacted with local groups of public, and we explained what exactly is eclipse, what is happening there, and what is the significance of that total solar eclipse. All that we explained. So I believe, I mean, with whomever the public, general public I interacted, they are very much interested. They are very enthusiastic to know about this, because they never heard, perhaps. Even if they heard, they don't know the details, and they are very much interested in this. So if people are so much interested, that will generally improve the overall the physics background, and they will be very much interested to getting into these fields. So in that sense, I'm very much happy that these podcasts are happening.
अभी आपने सुना हमारा ये खास कार्यक्रम. हम उम्मीद करते हैं कि आपको ये कार्यक्रम पसंद आया होगा. अब मुझे दीजिए अनुमति. नमस्कार.